Swayam Prabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on welded joint analysis. That means how to analyze a welded joint, that related things I will going to deliver in today's lecture. There can be different types of analysis in welding structure, like it can be static analysis, it can be dynamic analysis, it can be transient analysis, it can be fatigue analysis. But I will concentrate more in this course which is related to static analysis. Static analysis means the structure which is subjected to a load which does not vary with time. It is a time independent types of loading condition that you can say. That means here the load does not vary with time. So, that is called static analysis. So, these are the content of today's lecture. Here first of all I will introduce about the type of weld joint, then I will discuss about how to select the type of bar joints, that means selection of the type of bar joint, then I will discuss about the strength of bar joint, then I will solve some problem on butt weld, then I also will discuss about strength calculation of parallel fillet weld, and also I will solve problem on parallel fillet weld. So, first of all the type of joint, because this is very introductory things, because before going to discuss about the actual analysis of welding structure, first and foremost things we should know the type of weld joint. So, that is why here initially I am just discussing these things. So, we are very well familiar with different types of weld joint. We can categorize this weld joint into 5 different basic joints. You can see these are all called bar joint, T joint, lap joint, corner joint, edge joint. So, here in right side I have shown that what is bar joint. Here you can see this first one is called bar joint, where generally the two workpiece plate or you can say two component of a structure which is lying in same plane side by side, that you can say, and finally welding is done. Okay. So, these types of joining is called bar joint. Another one is called T joint, where generally there is a horizontal plate, over there is a vertical plate, you can say. This is horizontal, this is vertical plate, and these two workpiece generally we join together by using welding method. Here you can see this is called T joint. Why it is called T joint? Because the shape of this structure is T type, that is why it is called T joint. Now, the another one is called lap joint. Here generally two workpiece overlap each other, after that generally the welding is done at is edge, you can see. So, this is called generally lap joint, because here two overlapped plate we are joined together, or two overlap workpiece we join together. Another one is called corner joint, where the two workpiece lying in such a way so that a corner is formed. Here you can see corner is formed. In this corner generally we use the welding operation and do the welding. Okay. Another one is called edge joint. So, here you see here edge is formed by two component of a structure. So, after that generally the welding is done in this edge, that is why it is called edge joint. Now, you see this joint also can have different types of subcategories. Say this is depends on what? This is depends on its type of edge preparation. So, that is why you should know what is the different types of edge preparation. Generally, we used to do the following edge preparation, which is required for a strength requirement and some other design consideration, you can say. So, these are the following 6 different edge preparation which are most commonly used in actual field, that is why I am showing here. One is called a square edge. So, here using a square edge means at the edge of this joining surface which is generally perpendicular to the plane of this surface, you can say, or that means this weld face, or you can say this weld face also sometimes is called faying face. Okay, this is also called faying face. So, you see this faying face generally perpendicular to the surface of this weld plate. So, it is called a square edge preparation. Another one is called bevel edge preparation. Bevel edge preparation means this is done by using some milling operation, or you can say by some grinding operation also you can make this bevel edge, or some other machining operation also you can make this bevel edge preparation. You see this angle between this perpendicular line and this angular edge is called generally bevel angle theta. Now, there can be single bevel types of edge preparation, there can be double bevel types of edge preparation also. Double bevel types of edge preparation means along the mid thickness of this plate, top side on bevel operation and bottom side also another bevel operation is done. So, this is called double bevel edge preparation. This double bevel edge preparation generally we used to do once the plate thickness is little bit higher side in the sense which is generally we consider there is a generally once the plate thickness is more than 30 mm, generally there we prefer to use doubles bevel edge preparation. There we can use chamfer edge preparation. Chamfer edge preparation means where which is a combination of, you can say, bevel types of edge preparation as well as a square edge preparation, that you can say. That means the shape of this edge preparation is chamfering type, that is why it is called chamfer edge preparation. Now, there can be J group edge preparation. Here you see this is J group edge preparation. The shape of this edge preparation is like J in nature, that is why it is called J group edge preparation. Okay, it is like this right side. If you draw the edge preparation, then you can see it is generally J in nature, this shape. Okay, this is called J group edge preparation. Once the plate thickness is higher side, then we can make double J group edge preparation. That means both the side of this plate we can make J group. So, as two different edge group we are making both the side, that is why it is called double J group edge preparation. So, these are the very common edge preparation which we generally use depending upon the plate thickness and you can say depending upon the situation. Okay. These are the things which is required for strength requirement and some design consideration. Now, we will discuss little bit in details about butt joint, because in this lecture I will show you how to analyze butt weld joint as well as plate weld joint. So, first of all we should know what is a butt joint. So, butt joint is formed when generally two pieces to be welded are laid side by side. That means here you see this is one piece of weld, this is another piece of workpiece. This is generally laid side by side. After that generally welding is done in between. Okay. So, it can be defined as a joint generally which is formed between two component which is generally laying approximately in same plane, you can say it is generally laying approximately in same plane, okay, the same plane. So, this butt joint generally depending upon this edge preparation can have different subcategory, like here you see this first one is called bevel groove butt joint, this is double bevel groove butt joint, because these are all based on this above different types of edge preparation. So, depending upon this edge preparation it can have different names. So, to hear the name itself you can say that what should be the edge preparation required, what should be the shape of this groove, that you can easily be able to identify. That I am showing this thing. Okay. So, this is generally called V groove butt joint, double V groove butt joint, J groove butt joint, double J groove butt joint, U groove butt joint, double U groove butt joint. Here you see the shape of this weld groove, or you can say joint, general shape of this joint is U in nature, that is why it is called U groove. If both side this U is made, that is called double U groove butt joint. Here one thing you should keep it in mind, this butt joint generally is one of the most widely applicable joint. Here another things also you should keep it in mind, generally this bevel groove and V groove are easier to prepare, but what happens, this J group and U group generally required costly machining operation, which is more time consuming also. Okay, that is why this Bevel group and V group S preparation are widely used. Now, here I am going to show you what should be the selection procedure of the type of butt joint. Here one thing you should keep it in mind, this selection of butt joint, that means what should be the S preparation required in a joint in case of butt weld. Here one thing you should keep it in mind, it is dependent on thickness of the plate. In some design book there is some general rule, you can say. In some design book you will find that when the plate thickness is less than 5 millimeter thick, then for that case generally no S preparation is required. So, here in first example, that means in figure A I am showing, here there is no S preparation is required, that means here we are using A square S preparation, and so here whatever the welding we do here, that is called generally A square butt joint. Once the plate thickness goes from 5 to 25 millimeter, then there is required to make S preparation. What I am telling, understand? So, here I have already written here. So, once the plate thickness increases, then this type of S preparation also changes. So, you see 5 to 25 millimeter thick plate, here we can do by using V group S preparation, that means here we used to do Bevel S preparation. Here you can see in figure B I am showing. So, here the shape of the weld bit is V in nature, you can see. So, that is why it is called V group butt joint. Here another things also you can keep it in mind, that means when the thickness of the plate is more than 20 millimeter, then the edge of the two plate are machined to form a U shape. That means once the thickness of the plate goes above 20 millimeter, there we can use what it is called U group types of S preparation. What I am telling, understand? There we can use U group types of S preparation. Now, here another things also you should keep it in mind, when we should use double sided V group S preparation or V weld, that also we should know. So, double V butt joint generally preferable once the plate thickness is more than 30 millimeter. So, once the plate thickness is more than 30 millimeter, a double welded V joint is generally used. This joint is generally welded from both the side of the plate. So, that means from top side as well as from bottom side we can do the weld. Okay. So, these things just you should keep it in mind, because this is the procedure which we should follow during the welding operation. Now, we will discuss about fillet weld. So, what is a fillet weld? A fillet weld generally consists of an approximately triangular cross section joining two surfaces at right angle to each other. What does it means? Here you see. So, this is a plate. So, another plate is right angle to like this, this is a vertical plate, this is a horizontal plate. So, here generally the fillet welding is done in between two surfaces which is generally almost perpendicular to each other. So, this is one surface, this is another surface. So, here generally this fillet welding is done. Here you can see. In this case also here I have shown, this is one plate, this is another plate. Here you see at this edge I have done a fillet welding which shape is triangle in nature. So, these things you should keep it in mind. So, a fillet weld consists of an approximately triangular cross section. So, this weld cross section, if you will see, its shape is generally triangle in nature. Okay. Now, depending upon this type of load acting on structure, this fillet weld can be categorized into two different categories. One is called transverse fillet joint, another one is called parallel fillet joint. Now, so what is transverse fillet joint? Transverse fillet joint means here, this is the weld direction, you can say, along this direction welding is done. So, and this force is acting perpendicular to this weld direction, here you can see. That means the loading direction is perpendicular to the weld direction, that means transverse direction. So, once the structure which is subjected to load which is perpendicular to its weld direction, that type of fillet weld is called transverse fillet weld. So, here I have defined this thing. A fillet weld is called transverse fillet weld if the direction of the weld is perpendicular to the direction of the force acting on the joint. That means, here whatever the joint is formed, here this load is acting perpendicular to this joint, you can see. Now, here one thing you should keep it in mind, in case of fillet joint, a single transverse fillet joint is not preferable. You see, let this is one plate, this is another plate. So, here a triangular fillet joint we made. So, this is called a single transverse fillet weld, because here the load let is acting in this and this direction. This is transverse direction, because here the weld direction is like this. So, this loading is perpendicular to this weld length, loading is perpendicular to this weld length. Here once this fillet is done in one side only, then this is called a single fillet, and depending upon the loading condition, it is called single transverse fillet joint. This single transverse fillet joint generally not preferable, because the edge of the plate which is not welded, here you see this lower plate generally this edge is not welded here. So, which is not welded can wrap out of shape. So, the edge of the lower plate is free to deflect here. That is why what happens, this single transverse fillet is not preferable. This you should keep it in mind. Why? Because this can wrap out of shape. That is why this double transverse fillet generally preferable. So, therefore, here I have written a double transverse fillet which is shown in figure B, you can say is more preferable. Okay. Here you see, now I am going to discuss about longitudinal fillet weld. So, in longitudinal fillet weld, here the loading direction is parallel to the length of this fillet. This you should keep it in mind. Okay. So, a fillet weld is called parallel or longitudinal types of fillet weld if the direction of weld, that means here the direction of weld is this direction, if the direction of weld is parallel to the direction of the force acting on the joint. This force here you see, here this force is acting which is parallel, which you can see this is the force line of action which is parallel to the fillet weld length. Okay. That you can see. So, here this loading direction and fillet weld length direction is parallel to each other. So, these types of fillet weld is known as longitudinal fillet weld, or you can say parallel fillet weld. Okay. So, there are generally two different types of cross section of fillet weld we can get. One is called normal fillet cross section. This normal fillet cross section generally is a isosceles triangle. This triangle have two sides with equal length. This you should keep it in mind. So, whatever the side length is in horizontal direction, in vertical direction also this side length is same. So, this is a isosceles right angle triangle. And another types of cross section of fillet weld is generally called convex types of fillet weld, which I am showing in this figure B, you can see. So, this convex fillet weld generally require more filler material, as well it require more labor also. So, a convex fillet weld generate more stress, or you can say there is more stress concentration in a convex weld compared to triangular, or you can say normal fillet weld. Therefore, normal fillet weld is more preferable over convex fillet weld. This also you should keep it in mind. Why I am discussing all these things? Because this will be required once we go for analyzing this welding structure. Okay. Now, here I am showing some other types of joint which is generally done by using this fillet weld in the sense this shape of the weld is triangular in nature. So, one of the joint is called T joint, another one is called corner joint, another one is called edge joint. Here you can see this is the figure A represent the T joint, where one is horizontal plate, another one is a vertical plate, which form a shape which is look like a inverted T, you can see T letter, okay. That is why it is called T joint. But here the welding is done by fillet weld, you see the shape of the weld is triangular in nature. Similarly, this corner weld also is done by fillet weld, here you can see, okay, because the shape is triangular in nature. Similarly, this edge joint also, here the weld shape joint shape is triangular in nature, you can see. So, these are all generally done by fillet weld, but this is weld is fillet, but joint is depending upon the position of the two component, okay. Here you see depending on the position of this first two component is shown in figure A is called T joint, then second one is called corner joint, and figure C represent the edge joint, because here a edge is formed. But the weld which we are making here, this weld shape is triangular in nature, which is called fillet weld. Now, we will discuss about strength of butt weld first. So, generally a butt weld which is subjected to a load P, which I am showing here in this figure. This is a butt weld here you see, because here two workpiece lying side by side, and in between generally this welding is done. So, here on this workpiece is subjected to a tensile force P here, then the average tensile stress in the weld can be find out by sigma T equal to P into P divided by H by L. What does it means? So, here you see we know once a body subjected to some external force P, then internal to this body internally there is developed some resisting force which is generally equal to this external force. So, if we take a section XX, in this section generally there will be develop a resisting force which generally oppose this external force. Okay. So, if we take a section XX here, so here we are seeing there is develop a resisting force P, which direction is opposite to this applied force P. This you should keep it in mind. So, what is called stress? So, the stress is this resisting force, the stress is represented, if it is a normal stress, this is represented by symbol sigma. So, this stress sigma we can write as this resisting force divided by its cross sectional area. This cross sectional area of what? This cross sectional area of this plane over which this resistance force is acting. Now, here you see, to find out the stress in the weld section, what are the things required to do? Let us here you see a external force is applied P. So, in this weld zone, if we take a section cross section, so what should be the cross section here? So, the cross section of this weld will be, here you see the cross section of this weld will be what? The cross section of this weld, I am representing AW, will be your, you see, A is into L. L is the length of the weld, H is the, you can say, H is called throat thickness. Throat thickness. So, this is the cross section over which this P external force generate a resisting force. If this external force is tensile in nature, so in this weld cross section there also will develop a tensile stress, or you can say tensile normal stress. So, this tensile normal stress we can represent as sigma T, which is equal to your P. This P should be the resisting force which is acting opposite to the direction of this externally applied load, and whose magnitude is same or as externally applied load. So, stress is always calculated based on resisting force inside internally developed in the structure due to external load. Now, this stress, normal stress we can write as this resisting force P divided by the cross sectional area of this weld. So, what should be the cross sectional area of this weld here? The cross sectional of the area of the weld will be your throat thickness, which is generally in case of butt weld, this throat thickness is equal to the thickness of the plate. So, here this throat thickness in case of butt weld generally consider as thickness of the weld. Here one thing you should keep it in mind, that means whatever the, in case of butt welding you can see, in case of butt welding the joint is look like this. So, this is actually the plate thickness T, or it is equal to your here throat thickness, but you see above the plate thickness there is some extra volume of material, that is called generally bead height, weld bead height. Similarly, bottom side also there is some extra portion which is generally extruded out of this bottom surface, you can say. So, this is generally called bottom bead height, or you can say it is called bottom reinforcement. So, this portion and this portion is called top and bottom, this is called top reinforcement, this is called bottom reinforcement. Always keep this thing in mind when we go for analyzing welding joint, especially for butt joint. There generally this upper bulging part and lower bulging part is not required to consider, because you see here generally we should consider the throat thickness region for calculation purpose. Here you can see, because this plate which is subjected to the load, here you can see, which is generally subjected along its thickness direction only, which is acting along the thickness. Okay, here you can see. That is why in this case also here I have written this thing, the throat of the weld does not include bulge or reinforcement. This top side, that means this bead height, or you can say this bulging portion, or you can say this top reinforcement portion. So, this bulge is generally provided to compensate for flaws. So, this bulge, that means top reinforcement and bottom reinforcement is required to provide to compensate the flaws if there is inside this weld joint. So, from this equation 1 we can write this applied force P, which will be equal to your sigma T into H into L. Okay. So, this equation is generally called as a strength equation of butt joint. What it is called? A strength equation of butt weld joint, or we can say butt weld. What does it means? Because you see, if we know, that means okay, the weld have a permissible stress, or weld have a permissible normal stress, you can say. If we consider this sigma T is the permissible normal stress of this weld material, then we can say what should be the externally applied load. What should be the externally applied load? That means if this is this sigma T is the permissible strength, or you can see if the sigma T is the permissible normal stress of weld material, then what we can say, how much external load this weld structure can sustain, that we can beforehand calculate. What I am telling you, understand? That means what should be the externally applied load a weld joint can sustain, beforehand we can calculate if we know the permissible normal stress of that weld material. This you should keep it in mind. So, this equation which I am showing here, let this is equation number A, is called a strength equation of butt weld. Now, in case of butt weld, generally there is used some sort of classification rule, you can say, or you can say there are certain codes like code for unfair pressure vessel, which suggests that reduction in strength of the butt welded joint by a factor. This reduction factor is called efficiency of this joint. So, if we incorporate efficiency of this joint, then this strength equation of butt weld generally converted to, here you can see this strength equation of butt joint generally converted to P is equal to this efficiency into L into T into sigma T. Okay. So, where one thing you should keep it in mind, here generally the H is equal to here your plate thickness T. Okay. This you should keep it. That means, here in case of butt weld, throat thickness should be equal to your plate thickness. This you should keep it in mind. Now, if we incorporate the efficiency here, this eta is called the efficiency of this bar joint, efficiency of this bar joint, and here sigma t is called permissible normal stress of this bar joint, permissible normal stress of weld, normal stress of weld. So, if the permissible stress is sigma t, then we can easily find out how much load this structure can sustain if it is subjected to a bar weld. Now, we will solve a problem based on this bar weld. This is the problem statement of this bar weld. So, here it is shown that a gas tank, here you can see a gas tank consists of a cylindrical shell of 2.5 meter inner diameter. So, here you see this inner diameter D is given as 2.5 meter, that means this is the, let us inner diameter, it is 2.5 meter. It is enclosed by a hemisphere, here you see this is one hemisphere, this is another hemisphere. Okay. So, this gas tank generally enclosed by this hemisphere both side, this hemisphere. So, this is generally enclosed by hemisphere shell by means of bar joint, here you see bar weld joint as shown in this figure. So, this is one hemisphere, this is another hemisphere, these two hemispheres generally joined together with this cylindrical gas container by using bar weld. Here you see this is black color represent one bar weld, this is another bar weld, okay, that you can see. Okay. Now, you see the thickness of the cylinder shell. So, here thickness of the cylinder shell is given as 12 millimeter. Okay. So, determine the allowable internal pressure to which the tank may sustain. So, we have to find what should be the pressure, a small pressure P inside this tank, so that the weld should not crack, or you can say this weld joint should not fail. Okay. So, determine this allowable internal pressure to which the tank may be subjected if the permissible tensile stress is 85 MPa megapascal. That means, this weld permissible stress is given as 85 MPa. So, assume the efficiency of the weld joint, here also it is given efficiency of this weld joint eta equal to your 0.85. So, what are the things required to do? We have to find out what should be the internal pressure of this gas, so that it should not fail. That internal pressure, a small p, we have to find out. Okay. What is the internal pressure? So, for finding out these things, what we can do, I am just taking this hemisphere portion, here I am drawing. So, hemisphere portion. So, here you see, so if we just draw in 3-dimensional way, how it look like, just this way I am just showing. This is the hemisphere portion. Now, you see this hemisphere portion, it has a internal diameter d, which is given as 2.5 meter. You see this 2.5 meter is given, and this hemisphere, this thickness also given as t equal to 12 millimeter actually 12 millimeter. So, you see, so if we draw like this, so this is the hemisphere thickness, let us say I am just drawing in a little bit bigger way. Now, you see this internal zone, it will generally create a pressure projection, that is that if we take the projected area of this hemisphere, how the pressure will act. So, the pressure will act in this projected area like this, correct. This pressure generally, this pressure, or due to this pressure whatever the force will develop, this pressure force, so this is generally the pressure P P which is acting along this projected area of this hemisphere welding zone region. Now you see this periphery, generally periphery of this hemisphere in inner cylinder subjected to welding. So, subjected to welding you can say. So, what is the total weld length here? So, here first of all we will find out what is the total weld length. So, total weld length of one hemisphere connecting with this cylinder. So, here we are getting this length of the weld which is generally made to connect hemisphere with this cylinder will be your 2 pi into radius of this hemisphere, or you can say your pi into d. So, the cross sectional area of this weld which is the peripheral cross sectional area of this hemisphere we can say, or we can say peripheral area of this cylinder we can say, inner cylinder we can say. So, here the cross sectional area of this weld will be your 2 pi r, or you can say pi into d into your thickness of the hemisphere, or you can say cylinder. So, here thickness of the cylinder or hemisphere is given as t equal to 12 millimeter, here it is given already, because here we generally consider thickness or throat thickness of the plate, because we know in case of butt weld joint we generally consider thickness of the plate equal to your throat thickness H. This you should keep it in mind. So, this is our weld cross sectional area. So, due to this internal pressure, whatever the internal pressure it is applied in this projection area, this internal pressure will be resisted by the force acting in this welding zone. Let this is the force acting in this weld zone, okay, over the inter circumferential area. So, here I am, instead of writing this thing, there will develop a normal types of stress. Instead of force, here I am writing sigma t. So, this internal pressure should be balanced by the stress developed in in weld material. So, from this figure, let us say here I am representing figure A. From this figure, if we just write the equation of equilibrium, what we can get? We can get this what should be the total force acting in this weld. The total force acting in this weld will be your, we know this cross sectional area of this weld into this sigma t into its efficiency. So, what we can write? So, here we can get, first of all we will find out this sigma t into pi into d into t, this is the cross sectional area. So, this is the weld strength equation I am writing, sigma t into pi d into t into its efficiency. So, this will give you all the you can say load which is supported by this weld material, which is supported by this weld thickness, this you can see, okay, this weld thickness, or you can say peripheral weld joint. Now, from here generally we are getting what is the strength equation of this one weld joint. So, this strength generally balanced by this internal pressure. So, here you see, so this strength P should be equal to your internal pressure, let us say small p, internal pressure small p into this projected area of this internal pressure. So, here projected area of this internal pressure will be pi r square, or you can say p into pi d square by 4, correct. So, from here we have to calculate what is this a small p. So, we can easily find out. So, this a small p should be equal to your this p capital P divided by pi d square by 4. So, what we got, because how these things is coming, because this resistance which is developing in the weld material, this resistance force is balanced by this internal pressure force. How these things is coming, you should understand this concept, okay. So, here we are applying this equation of equilibrium. So, by equation of equilibrium, what condition we should apply here? Here we will use summation of force along horizontal direction should be equal to 0, should be equal to 0. So, what are the force here generally acting? So, one force which is acting which is tensile in nature, which is on weld, in weld zone, that is generally your this force P. Another force is due to the internal pressure, which is actually your internal pressure into its projected cross sectional area, that is pi r square, which I am showing in this equation number. You can say equation number, this is 2, this is equation number 1. So, by using this equation number 1 and 2, what we can get? We can get this small pressure is equal to your, this small p represent the pressure, which is actually your P divided by your pi d square by 4. What is P we got? This P we got as sigma T into weld cross sectional area into its efficiency. So, this is generally balanced by this internal pressure force pi d square by 4. Okay. Now, if we just put all these things, so pressure, internal pressure P will be your equal to your sigma T is given as directly here I am putting all these value, then it will be more clear to you. So, here we are getting sigma T is 85 MPa is given. So, 85 MPa, once we convert it into this 85 MPa itself, here all the things I am putting in millimeter. So, 85 MPa is equal to your 85 Newton per mm square. This you should keep it in mind. Here cross sectional area AW equal to your pi is D is generally is given, D is 2.5 meter, 2.5 into 1000 I am writing. So, pi D, this is pi D, and its thickness is T, which is generally 12, thickness is T 12, and efficiency is also given as 0.85 divided by pi, its diameter is given as 2.5 into 1000. Okay. This divided by 2 you can write whole square. So, from here generally we can get the internal pressure, or you can say permissible pressure of this cylinder will be equal to your 1.39 Newton per millimeter square, or you can say 1.39 MPa megapascal. This you should keep it in mind. So, for designing this cylinder generally once you manufacture a cylinder based on this types of thickness and these types of weld material permissible tensile stress, then this cylinder internal pressure should not exceed, you see, 1.39 MPa. If it is more than this, then there is a chance of failure of that cylinder. So, that is why what happens by these types of methodology, once a structure subjected to some weld joint, then we can easily find out what should be its internal pressure, or if internal pressure is given in the cylinder, then what happens, or internal pressure is still given in this chamber, you can say, or you can see this gas cylinder, then what should be the thickness, what should be the weld material permissible stress, that also we can beforehand find out. So, based on these things, if we just do the welding and if we just decide the thickness of the plate, then our structure will be safe side. This you should keep it in mind. Now, we will discuss about strength of parallel fillet weld. So, parallel fillet weld, what I have already told you, a parallel fillet weld which is subjected to a force, you can see in this figure A, this force is generally parallel to the direction of the length of the weld. Okay. This is the length of the weld. So, here the load is also which is parallel to this length of this weld. This you should keep it in mind. Fillet weld joint which is called parallel fillet weld joint. Now, here in case of parallel fillet weld joint, one thing you should keep it in mind. In case of parallel fillet weld joint, there generally we use two different terminology to find out the dimension of this fillet weld. So, these two terms to find out this dimension of the fillet weld, one is called leg ace, another one is called throat T. So, here the size of this weld generally is specified by this leg length, and this throat thickness is very important parameter where generally most of the failure occur in case of fillet weld joint. That is why T is also another important dimension. This you should keep it in mind, but the fillet size generally we specified by this leg length ace. The length of the each weld generally the length of each of the two equal side is called leg. So, let this is a fillet weld which I am showing here. Let this is a fillet weld. We know this fillet weld generally have a triangular shape. So, you see from here to here, this is called one leg, this is called another leg. So, in case of fillet weld, we generally consider this two leg are equal to each other. Okay. This you should keep it in mind. So, here these things I have written also. This leg length also generally consider as the thickness as equal to the thickness of the plate. That means, whatever the plate we are going to join, let this is one plate, this is another plate. Okay. So, what should be this leg length ace? So, this leg length ace generally always keep this thing in mind. This leg length ace generally consider for design consideration, which is equal to the thickness of this, plate. That is why here I have written as a rule the leg length ace is equal to the plate thickness. The throat thickness generally is the dimension which is generally at a angle of theta with horizontal axis. This you should keep it in mind. So, throat thickness generally acting at an angle of 45 degree, that means theta equal to 45 degree with this horizontal axis. So, whatever the distance here we got this T throat thickness. So, here generally throat thickness I am representing in terms of T. So, a small t, and plate thickness here I am representing, let us is 1. Okay. Plate thickness I am representing in terms of is 1. Okay. So, say this throat thickness generally makes a angle 45 degree with horizontal line, you can say. So, whatever the dimension we got here, this is the minimum dimension of this weld, you can say. As this dimension is the minimum dimension of this weld, that is why whatever the cross section we got in this throat thickness region, that is the minimum cross section of the weld, you can say. So, in this throat thickness, as it has minimum cross section, that is why most of the failure in case of fillet weld generally occur along this minimum cross section zone. Why in minimum cross section zone? Because you know we know that stress is equal to your load by cross sectional area. So, if this cross sectional area is small, that means if the cross sectional area is decrease, then this stress magnitude increase. So, that is why where there is minimum cross section, there the stress will be more. That means then what happens, the chances of failure will be more in that section. That is why here I have written the failure of the fillet weld generally occur due to shear along the minimum cross section at throat, because in minimum cross section zone generally maximum shear stress will be developed. How this maximum shear stress is developed in throat thickness direction, that also I will show you in details. So, the shear failure of weld here I am showing. The shear failure generally is why it is shear failure, because in this throat thickness, whatever the area we will get here, you can see this area will subjected to a force which is generally parallel to the surface. So, we know once a force which is acting, once a force which is acting parallel to the surface, then that types of load, whatever the stress is developed, that stress is called shear stress. Because here as this force which is parallel to the throat surface area, that is why what happens, whatever the stress here it will be developed, that will be shear stress. So, due to this shear stress, whatever the failure will be taken place here, that is called shear failure. How this strength of this parallel fillet weld is calculated, that also I am going to show you. Okay. Let us one side, first we are considering one side fillet weld, but we know one side fillet weld is not preferable. We should use both side fillet weld. We should use both side fillet weld, correct. So, first of all we will calculate based on one side, after that we will convert it into both side fillet weld. Okay. So, we will calculate the strength of this fillet weld now. So, for calculating the strength of this fillet weld, so here let the throat thickness here I am representing in terms of T, which I am showing in this figure. Okay. So, here I am just further I am drawing little bit bigger way. So, let this is the fillet weld. So, we know this throat thickness here, this is your T, throat thickness T, which is generally acting at angle theta, which is 45 degree, and this is the leg length H. We know this leg length H is equal to, so this H is the leg length and T is the throat thickness, T is the throat thickness. So, what should be the cross sectional area of this throat thickness region, that we should know if it is subjected to a force which is parallel to this throat thickness direction, or you can say which is parallel to this weld direction. So, here we have to find out the throat thickness area. So, here throat thickness cross sectional area will be your, I am representing AT, which will be your you can say throat thickness into length of the weld. So, length of the weld here it is given as let us L, length of the weld. So, here it is called length of the weld. So, length of the weld and its throat thickness, this throat thickness will give us the cross sectional area of the throat region of this weld. So, this cross sectional area is subjected to a external force P. So, if this is subjected to external force P, then what should be the shear force on this throat section, that also we can easily find. So, the resisting shear stress, let us its tau. So, this tau is the shear stress, here I am writing. So, shear stress tau on this throat cross section will be your this force external due to this external force, whatever the internal force developed in this throat cross section, that also will be equal to your P. So, this P divided by throat cross sectional area. So, what are the things we are getting here? So, we are getting here P by T into L, but this T we can represent in terms of what it is called a leg length H. How? Because here you know that T by H we can write as this T by H will be equal to your cos 45 degree, correct. T by H equal to your cos 45 degree. So, we can write T is equal to your, from this figure itself you can see. So, T we can write as 1 by root 2 into what it is called 1 by root 2 into H. So, throat thickness we can say this 1 by root 2, its value will be generally 0.707 into H. So, here what we are getting, so shear stress in a fillet will be tau equal to your P divided by your 0.707 H into L, correct. This you can get from this equation. So, what is the strength equation of this parallel fillet weld? So, the strength equation of this parallel fillet weld we can write P is equal to your 0.707 into L into tau. This is called the strength equation of a parallel fillet weld. Once there is only single weld, but we know for a fillet weld to be in proper strength, generally both side fillet welding is required. So, if there are two different fillet weld both side of this vertical fillet, then this P strength. So, for both side fillet weld, here one thing you should keep it in mind, here this P should be your that means this strength equation will be your 2 into 0.707 H into L into tau. So, this we are getting as 1.414 H into L into tau. So, this is called the strength equation for parallel fillet weld, strength equation for parallel fillet weld. Okay. So, based on this strength equation, whatever the length we will get, generally for designing purpose, we should add 15 millimeter more length over this L, because this 15 millimeter, that's why I have written at the end of this slide, you can say, in determining the required length of the weld, 15 millimeter should be added to the length of each weld to allow for starting and stopping of the weld run. This you should keep it in mind. So, this 50 millimeter weld length we should add for each weld, this you should keep it in mind. So, whatever the L we will get here, with this once we add this 15 millimeter, then what happens, the final length, whatever the length we will get, that should be our final design length. This you should keep it in mind. So, next lecture I will start from here. I will solve different problem on this parallel fillet weld, as well as I will discuss about transverse fillet weld and how to calculate strength of this transverse fillet weld. That details also I will discuss in next class. Thank you.